Okay, and again, I always want to point out NIDA has some help sometimes. And it's going to tell us what we need to do. We're going to need to get total inductance, total inductive reactance, total resistance, total impedance, total current, branch current, and then check for total current again. So we'll systematically follow NIDA. It tells us that we can take product over sum. We're going to have to do it twice because there's three. L1 times L2 over L1 plus L2. Get that equivalent. Do that with L3. Or, as I've told you, there's another way, and that is to do the reciprocal. So, oops, I pressed the wrong one. Let's get back. So, if we want total inductance, LT, I'll show you how to do the reciprocal version of that, which I prefer. So, it is 60 reciprocal plus 60 reciprocal plus 60 reciprocal equals, reciprocate that, and we got 20 millihenries. So let's write that down so I won't forget. So I'm going to come up here and I'm going to try to keep this a little area up here. LT equals 20 millihenries. So there's that. So let's go back down and let's choose help again. So we've got our LT. Now we've got to do our total inductive reactance, our X of LT. So let's go ahead and write what we're aiming for here. X of LT. We've got to calculate that. And this is the 2 pi FL formula. And we're going to do it on the 20. So we're going to say 2, actually we're going to just do 2 pi, which is 6.28 times frequency 40, and it's in kilos, times X of our LT, which is in millihenries, so they'll cancel, so we can use base units. Our X of LT is 5,024, so we're just going to make that 5.02 K ohms, shall we? So let me write that down. 5.02 K ohms. Alright, so there's that. So now, let's see what it's telling us to do next. Total resistance. Well, that's pretty doggone easy. We only have one. So I'm going to come up here. We'll do a different color so it doesn't get confused. But we'll write, how about RT equals 5K ohms. So there it is. So we'll go back to where we were. Again, it's only because there was only one resistor, this 5K, that we could do that. So we got a running record. So now we got a total impedance, and this is ZT, and this is this great formula right here. We've got it written up here, so since I've got plenty of blank space, I'm going to utilize it before we go back to our other. So we're going to write ZT equals RT, which is 5K times 5.02K over the square root of 5K squared plus the 5.02K squared. And I know that's really busy, and my writing is really terrible, but again, it's the best we can do. So let's go ahead and do the top part of our math. So 5 times 5.02 equals, now K times K gives us mega. So the top part of our equation is now 25.1 mega. That means times a million. Now we've got to do this part on the bottom. So 5K times 5K, we'll do that. So I'll just say 5 times 5, that's 25, and again, that's mega. No, yes, that would be mega, because it's RT, so 25 mega plus 25 mega. I'm sorry, never mind, just disregard that 25 times 25. So let me write what we just did. We've got 5K squared. So I squared 5K and I got 25. I don't know where I was going with that other, but just disregard it. So there's 25 meg. This is all under a square root sign. Plus, we've got to square 5.02. So let's do that. 5.02, we'll square it, 25.2 meg. So we've already got 25.2 in our calculator. I'm going to add the 25 plus 25 equals. So this becomes 50.2. And then we got to take the square root. So let's do that. So the square root of 50.02, which is these two added together, is 7.08. So I end up with 25.1 meg over 7.08. Now notice that was, originally we were in mega, but when we did the square root, we actually went down to K. And I'm going to show you that by showing you all the units total here. So what we did was we added 25 million, oops, that extra, 25 million, oops, still got an extra, plus 25.2 million. Whoops, I don't need to put the point. So let me start over. 25 million. It's hard to do when you're switching units here. Plus 25 plus 25,200,000, which is what this represents. We're in 50 million. Now when I get the square root of that, notice that's in thousands now. 7.08. This is K. So let me write K there so there's no confusion. So now we got to do that math. So I'm going to clear my calculator. So 25.1, which is in mega. So really we need to express, let's do it in all units. 25,100. That is 25,100,000 divided by 7,080, which is our K value right here, equals. So we came up with 3545. So ZT equals 3545, or 3.55, might as well say. So let's write that down. Okay. ZT equals 3.55 K ohms. So we're getting closer, but we're far from done. Still got plenty of math left to do. And just like you guys, I can make mistakes, and that's why sometimes I have to go back and kind of re-explain things. So let's go ahead and see what our next help was. We just calculated ZT. We've got it written up top. So that was total impedance. Our next one is total current, EA over ZT. So let's go back. Our E applied is 10 volts. 10 divided by, and it's ZT, which is up here, and we know it's going to be in milliamps, 3.55 equals 2.8 milliamps. So let's go ahead and write that in next to our I total. Because remember, we were down here, and the next thing we calculated was total current. So that's where we're at now. So right next to I total, I'm not going to put it in just yet, is the answer of 2.8 milliamps. So now, let's see where we're at next. We're going to do our IR and IL probably next. So we're going to do the branch currents of IR and IL, and those are easy. Take the applied voltage and divide it by the resistance or the X of LT accordingly. So let's get back here. And let's do 10 divided by 5. This would be milliamps because it was K. 10 volts divided by 5K. So this answer right here for our resistance is 2 milliamps. Now we've got to do the same thing with our X of LT. It's going to be darn close, I can tell you, because there's not a lot of difference between 5K and 5.02. Let's clear it. 10 divided by 5.02 gives us 1.99. That's easily roundable to 2 milliamps. So let's write that, 2 milliamps. And apologize for the scribble. But then there's one last formula we can apply, to get total current that it shows us here. And we're going to check it, and we're going to use that formula. So we know these first two are our I, R, and IL. So we're going to say just exactly what we see in this particular formula. If I can press the right button. So we're going to say IT equals the square root of 2 squared plus 2 squared. I can do part of this math in my head. 2 squared and 2 squared. 2 squared is 4, 2 squared is 4, so 4 plus 4 is 8. So IT is equal to the square root of 8. So let's go over here and put our calculator in. And we're going to say clear. We're going to say 8 square root. Look there, 2.8. Exactly what we had. That matches. So we checked our current the other way. We came up with total current one way. We came up with total current the other way. And we arrived at the same answer. So we feel pretty good about our answer. So I'm going to get rid of this stuff. Well, you can actually leave that at the bottom. So let's type in 2 here. We'll choose milliamps. 2 here. We'll choose milliamps. And we'll choose 2.8 here. And we'll choose milliamps. And we're going to hit enter. And voila, we are correct. So a lot of steps there to get there, but we got there, which is very important. So got an okay. Got it correct, and we've got another problem to work. We're about 12 minutes into this video, so I'm going to go ahead and pause it now. We'll resume with this one on the next video.